Hi, kids. Excuse me. Hi, kids. Okay, I'm going to try this one again. I've actually tried this video now. This is about my third time trying this one, so hopefully I'll get it right this time. I'm going to move me over here. All right, so we're going to take a look at some more problems, and these problems were sent home to you in a packet for this week. They're just reviewing some more questions from Unit 6. Hopefully we can wrap this up and be finished and ready to move on next week. So the first question is looking at a hanger diagram. And it says this hanger is in balance. There are two labeled weights of 4 grams and 12 grams. The 3 circles each have the same weight. So what we need to do with this is turn it into an equation that we can solve. And we can use this. We can just kind of look through it. We see that we have 3 x's. Wrong variable. We have 3 x's plus 4 on one side, and those balance out. They are equal to 12, which is what we got on the other side. So if we were to solve this just like any other equation, we would start out by subtracting 4 from each side. Okay, that's going to be our constant. Remember, this is called our constant. So we're going to subtract the constant from each side, and that leaves our coefficient and variable, and that leaves us with 8 on the right side. So the way that we get rid of the coefficient and the variable is we divide each side by 3. And that leaves us with 8 is equal to 8 over 3. So we see over here, if we scroll down just a tad, we'll see that 8 divided by 3 is actually one of our options. So our solution to this one is C. Okay. And we'll scroll down. Oh boy. The next one is a tape diagram. And this is a long one. So it says, let me move me out of the way again. I'll move over here. Okay. It says select all the situations that can be represented by the tape diagram. Well, when we have a tape diagram, the first thing that we need to do is make sure that we can turn it into an equation, something that we can solve. So since we have, looks like we have 1, 2, 3, 4, 5 W, we can rewrite this as 5W plus 4 is equal to 99. Okay. So we need to find one of the scenarios underneath, one of the situations that is represented by 5W plus 4. The easiest way to do this, you're just going to have to read through it and kind of work each one of them out and see if they fit. So we're going to have to just do that. I've got some scrap paper over here. The first situation says Claire buys 4 bouquets, each with the same number of flowers. The florist puts an extra flower in each bouquet before she leaves. She leaves with a total of 99 flowers. Well, we're going to take a look at this and see if this happens to match the situation that we have. So it says Claire buys 4 bouquets, and each have the same number of flowers. Well, kind of right off, we see we actually have something, our variable needs to be attached to something. It's going to be 5W, right? Our variable and our coefficient is going to need to be 5. So since it says they put an extra flower, puts 1 extra flower in each one, the constants don't match up. So by matching up those things, we don't even need to really work it out. We see A is not one of the situations represented by that tape diagram. Next, it says Andre babysat 5 times this past month and earned the same amount of money each time. Okay, well, it's kind of looking good. We have 5 times 1, 2, 3, 4, 5 times that Andre babysat. We don't know what his wages were, so it would be 5 times the wages that he earns. To thank him, the family gave him an extra $4, so they added $4 to the wages that they gave him. And then it tells us that Andre earned a total of $99. Well, when we write it out in an equation, you'll see that that equation matches exactly the equation that we got from the tape diagram. So B is a situation that fits that tape diagram. So that one is a good one. Next, it says a family of 4 drove to a concert. They paid $4 for parking. So whatever it is that they paid a constant of $4. That doesn't change. And all of their tickets were the same price. Well, there's 5 of them in the family, and they paid some amount. We don't know what the amount is for their tickets, but they all paid the same price. So it's going to be 5 times that same price plus the $4 for parking. And the total they paid in all was $99. Again, you'll see this equation matches exactly the 2 that we just did. So C is a situation that could be represented by that tape diagram. Okay. For D, it says 5 bags of marbles each contain 4 large marbles. Okay, so we've got 5 bags, 1, 2, 3, 4, 5. Okay, that looks good so far, contain 4 large marbles. So each one of those would have to be 4. We need 4. And right now we're seeing that that's going to be more represented by an equation that would look like this. 4 large marbles plus some number, we don't know what that number is, of small marbles. Okay, that's an L. Maybe I should change it to an X. Or a W. And this doesn't quite match up with what we've got up here, because this it actually will turn into 20W plus 20S. And that's just not even going down it's getting to be way too much. So we can see without even going any further that D does not match the scenario. So D is not going to be 1. We'll say, nope, not D. We'll just mark through it, however. Mark through it. Doesn't match. And then the last one, Han is baking 5 batches of muffins. Each batch needs the same amount of sugar in the muffins. So let's see if we could try it. 1, 2, 3, 4, 5. So he needs some sugar. We'll represent it with an S for now, just so I don't get confused. Each batch needs the same amount of sugar, and then an extra teaspoon of sugar for the topping. So it's going to need 1 extra. This already doesn't match up, because if we were to turn this variable into W's, we would have 5W plus 1. And 5W plus 1 is not the same as what we have up there. So for this situation, E also does not work. So your solution to this one, the scenarios that actually match, are going to be B and C. So B and C are possible solutions or situations that are represented by this tape diagram. They didn't leave a lot of room to write that one. Okay, I'm going to move me down again. We'll go down here. Okay. At practice, Diego does twice as many push-ups as Noah, and also 40 jumping jacks. He does 62 exercises in total. The equation 2x plus 40 equals 62 describes the situation. What does the variable x represent? Well, for this one, you don't even need to do math. You just need to figure out what x represents in this situation. And since we go back in the problem, we read he does twice as many push-ups as Noah, and also 40 jumping jacks for a total of 62 exercises. We'll see the only part we're missing is push-ups. So for this, X represents the number of push-ups that Noah does. Okay? Not the number of push-ups that Diego does, because he did twice as many as Noah. Okay? If you're wondering why it's not the number of push-ups Diego does, it's because since Diego did twice as many as Noah, it means he did more than Noah, so it's going to be 2 times X, twice as many as Noah. Okay? The next ones are going to be just solving in the equations, and we're kind of used to these. I want to move myself back up here, give me some room. And remember, I like to rewrite these so that they are in a format like we have been practicing over and over in class. So if we rewrite it, we're going to take this. This is a negative 3x. This is a positive 25, and we have to know that to be able to rewrite it in that format. So negative 3x plus 25 is equal to 40. Well, first thing we need to do, subtract the constant from both sides. And that gives us negative 3x equals 15. Then we have to get rid of the coefficient. The way we do that is divide it by itself. And we see that x is equal to negative 5. Oh, I almost skipped one. I'm going to move me down here. Okay, the next one, B, is the second part of number 4, and it says, or it has a fraction. And your first inclination may be to distribute this, but I want you to remember back that the easy way to do this, or what I consider the easy way, you may not find it to be the easy way, but for me, the easiest way to get rid of that fraction is just to multiply it by its reciprocal. And we can do that first. So that will get rid of this part altogether and leave us with x minus 10 equals, and this is negative 3. It doesn't look like it. Negative 4 times negative 3 is 12. Oops, sorry. That's not a negative 3. It's a positive 3. So negative 4 times positive 3 is negative 12. Okay? So now we need to get rid of this constant. We subtract 12 from both sides. 10. Subtract 10 from both sides. And we get x. You know what? I can't even read my writing. Let's start that one over. Okay, try it one more time. Take 2. When we multiply this by its reciprocal, times, it's a multiplication, times 3/4. There we go. Now I can read what I'm writing. It leaves us with x minus 10 is equal to negative 4 times 3. Negative 4 times 3, and negative 4 times 3. Negative times a positive is a negative, equals negative 12. There we go. Now we need to get rid of our constant on this side, and because it's a negative, or minus 10, there's a negative sign here. Subtract, we got to add 10 to both sides, plus 10. And that leaves us with x. Negative 12 plus 10 leaves us with negative 2. There, got it. That's it. Okay. So this is one where we need to find the mistake. And it says, Andre tried to solve the equation 1/4 times x plus 12 is equal to 2. Just like we just did, and I kind of messed it up a little. But ask, what is his mistake? So take a look at each step. It looks like he starts out trying to distribute because he has 1/4 x. But somewhere in the mix, he kind of loses this 12 here. Kind of loses it. Don't know what he did with it. So let's try to work it for him. Let's try it the way that he's trying to do it. He's actually trying to distribute it. So if we were to use the distributive method, it'd be 1/4 x plus 1/4 times 12. If we pretty much multiply that out, if we were to do that, we would get 3. So 1/4 of 12 is 3 equals 2. Well, we see he's already kind of messed up here. And I think if you notice what he did, he tried to do the distributive method, but it looks like he got the two of them combined. So let's compare the two. If we were to finish this one out, we need to subtract 3 from both sides, and we would get 1/4 x is equal to negative 1. Okay. Well, when we have a fraction that is our coefficient, if we multiply each side by its reciprocal, that's the same as dividing by a fraction. And sometimes people don't like dividing by a fraction, but that's okay. In this situation, we would get x is equal to negative 4. Now, if he had done it the way we just tried to do it, where, let's do that, he multiplies each side by the reciprocal first, he would get x plus 12 is equal to 8. Okay? And if we subtract 12, or the constant, from both sides, we will end up getting x is equal to negative 4. So there's the way to work it both ways. Each way we got the same answer, so we know that that's a good solution. And I think where Andre made his mistake was he tried to combine the two and he skipped completely what he needed to do with the 12. Okay. All right. So it says a food pantry is making packages. Each package weighs 64 pounds. Here are two situations. For each situation, write and solve an equation to represent the situation. Then explain what your solution means in the situation. If you get stuck, try drawing a diagram. So we're going to try to draw a diagram, kind of like what we did with those problems up above, and see if we need to do that. So it says each package contains 4 boxes. So let's draw out that diagram. Each package contains 4 boxes. Each contain a 7-pound bag of beans and a bag of rice. And we don't know how much the rice is, so we'll just make it X. And the bags of rice are all identical. Okay. So we'll make it into a solution that looks like that. And up here it tells us that these all together, each package total weighs 64 pounds. So if we were to work this one out or turn it into an equation, we've got 4 times 7 plus x is equal to 64. Now, you need to recall we had done some problems where you were needing to distinguish between which way you needed to write your equation. It could either be done in this format, p times x plus q equals r, or px plus q equals r. Okay, so write those down. Those are going to kind of help you. This particular scenario, this first one for A, you would need to use this first format, this one right here, because you've got 4 identical boxes, each weighing 7 pounds, and then an unknown amount of rice. And all of those combined is equal to 64. Okay, so let's work it out. 4 times 7, we've got 28 plus x is equal to 64. Again, we have that format. We can either rewrite the format, or if you're kind of used to it, go ahead and leave it the way that it is. Subtract 28, which is the constant, from both sides. You're going to get x is equal to 36. Oops, I skipped a step. Because I forgot. 28x plus 4. Oh, hold on. I already messed that one up. See what I forgot? Here's what I forgot. 28 plus 4x is equal to 64. Okay, so there's where I messed up. So we still need to subtract that constant. And that gives us 4x equals 36. And then we'll divide by the coefficient. 36 divided by 4 is 9. So each of the bags of rice, the rice weighs 9 pounds. Okay. Okay, the next one says each package contains 4 identical bags of rice. It's a different situation, so we'll draw a different diagram. Each package contains 4 identical bags of rice and a 7-pound bag of beans. So we'll put, and then the weight for all of those is 64. So this one is going to look like 4x plus 7 is equal to 64. And we will work that out. Subtract 7 from both sides. We will have 4x equals 57. And then when we divide it out, we will find that x is equal to 14.25. So each bag of rice in this scenario is 14.25 pounds. And our last question, number 7. For a school fundraiser, Elena will make t-shirts. She will order t-shirts and print graphics on them. Elena must spend $349 on the printing machine and $4.80 per shirt for the blank shirts, ink, and other supplies. Complete the table giving the total cost Elena will spend to make each specific number of t-shirts. Okay? So if we were to write this, turn it into an equation, it says that she was going to order t-shirts and print graphics on them. So our constant, the thing that's not going to change, is $349. Let's see, it's not giving me enough room. So we'll write it up here, $349. We'll put that one out. That's for the printing machine, and $4.80 per shirt. $4.80 per shirt for the ink and other supplies. Okay. So if we were to apply this, the same equation, we're to do 4.80 times 20. That's not an equal sign, that's plus. It's plus. That will give us our total cost in dollars. So let's see, we've got 4.80 times 20. Yes, I am using a calculator. You guys don't want to see me write all this out. It would give us $96 plus the $349. So that gives us a total of $445 if she makes 20 t-shirts. Okay. Give myself some more room up here. Next, we're going to do the same thing. We're going to replace x with 40, and we're just going to write 4.8 times 40 plus 349. That's an 8. Doesn't look like an 8. There we go. So 4.8 times 40, the number of shirts that she's going to make, plus the $349 will give us $541. Okay, next situation, if she orders 60 shirts, it's going to be 4 4.8 times 60 plus 349. And if we work all that out, we're going to get 637. And that's the 4.8 times 60 plus 349. We'll get 637. So that'll complete that table. Part B says write an expression for the cost of making N t-shirts. That's any number. So if we were to put any number, just like we did at the top, since it's $4.80 per shirt, and any number of shirts, we'll represent that with an N plus the 349, which is the exact same expression that we already wrote to solve this at the top. So it says, what is the maximum number of t-shirts Elena can make if she only has $1,000 to spend? Well, we're going to have to work that one kind of backwards. If she only has $1,000, we're going to have to start out by subtracting the number that we know, which is the cost of the printing machine. So when we subtract that, she will get she'll have $651 left. If she has $651 to work with, and each shirt is $4.80, we need to divide that out, and we'll see that we get 135.6. And she can't make 6/10 of a shirt, so we'll see that the maximum she can print or have printed is 135 t-shirts, because 136, if we round it up, that'll be too much. She won't have enough to do 136 shirts. Okay, and so that's the end of those sheets, and I hope this was helpful. I hope you enjoyed this video, and if you have any questions, feel free to email me or post any questions on our class discussion. Have a great evening. Thanks.